Today we're going to go over solving absolute value equations, but before we do that, let's just go back and review what does absolute value mean. Remember, absolute value is the distance from 0. So if I ask you how absolute value of 6, isn't that saying how far is the number 6 from 0? And isn't the number 6 units from 0? So don't we say it is 6 units? If I ask you what's the absolute value of -4, that is saying how far is -4 from 0? And isn't -4 4 units from 0? So notice that the distance from 0 must always be positive. You cannot have a negative distance. So this is the distance from 0. You cannot have a negative number. But what if this time we're looking at how the absolute value of what? So we're saying the absolute value of what equals 3. So the absolute value of what equals 3, what we're talking about is we're saying what number or numbers are 3 units from 0. So this is your distance from 0. So if I told you you need to be standing 3 units from 0, wouldn't you say, well, I could stand here or I could stand way over here? So isn't -3 3 units from 0? And isn't +3 also 3 units from 0? So this one is saying what number is 3 units from 0? And we would say, well, you could be standing at -3 or you could be standing at +3. So you could be standing on any of those numbers to be 3 units from 0. And we could write the answer using what we call set notation. So if I say what's the absolute value, so what number equals 7, I am saying 7 is the distance from 0. And we're saying what number is 7 units from 0? So if I say you have to be 7 units from 0, couldn't you be standing over here at +7? And couldn't you also be standing at -7? Aren't both of those numbers 7 units from 0? This one's on the negative side of 0, and this one's on the positive side of 0. But those numbers are both 7 units from 0. So we say x, you could be standing at -7 to be 7 units from 0, and you could be standing at +7 to be 7 units from 0. And then we could write our answer as -7 and 7. What if I say, what's the absolute value of 0? That's asking what number is 0 units from 0? So if I say you better be 0 units from 0, don't you have to be standing on 0? So doesn't x have to equal 0 and that's it? If you're 0 units from 0, don't you actually have to be standing on 0? Again, what if I say what's the absolute value of 8? I want to know what numbers, right? What numbers are 8 units from 0? So isn't the number 8 8 units from 0? And isn't the number -8 8 units from 0? So aren't there two values that have a distance of 8 units from 0? So here we could say you could be standing on -8 to be 8 units from 0, or you could be standing on +8 to be 8 units from 0. So our answer is -8 and 8. What if I ask you what's the absolute value of -6? I am asking what numbers are a -6 units from 0. When you're talking about distance, you can't have a negative number. Distance is just how far away you are from 0. We don't care whether you're on the negative side or the positive side. We just want to know, oh, I was 8 units away. Oh, I was 8 units away. So when you have a negative distance, there is no solution, right? When you have a negative distance. So now let's look into solving some equations. Okay, step one. Step one, you want to isolate the absolute value. That means anything, you have to undo any operations that are outside the absolute value first. Then the second thing you want to do is you want to check for a no solution. Remember, the distance cannot be negative. So if the distance is negative, then you have a no solution. And you only check for a no solution after you've done step one. And then step two is to write the correct number of equations. And then obviously step three is to then solve those equations that you just wrote. So let's look at problem number one. In problem number one, the absolute value is already isolated. There isn't anything outside of it. And you might be going, I don't get what you mean. Well, let's look at example number three. In example number three, isn't there a negative 6 outside the absolute value? So we'd have to undo that first. In problem 4, we've got an add 4 and a multiply 3 that's outside the absolute value. In number 6, we have an add 6 outside. And number 9, we have an add 4. Number 10, we have a subtract 1 and a multiply 3 that are outside. So what we mean by step 1 is to make sure that the absolute value is isolated, that there's nothing outside the absolute value has to be done first, undone, right? So in problem number 1, it's already isolated. So isn't that just asking us for what number is 8 units from 0? So couldn't m be standing at negative 8? And couldn't you be standing at positive 8 to be 8 units from 0? And then we're going to use set notation. Problem number 2. Isolate the absolute value. The absolute value is already isolated. So step 1 is already done. Check for no solution. You can't have a negative distance. So that would be a no solution. Number 3, we have to isolate the absolute value first, which means we have to undo subtracting 6 first. So we have to add 6 to both sides. And that's going to give us the absolute value. Got to write the absolute value equals 16. And then we check. So we did step 1. We isolated the absolute value. This is not it's a positive distance. So it's not a no solution situation. So we're good. And then we can write our 2 equations. So this is asking for, we need to be 16 units from 0. So if you're 16 units from 0, couldn't you be standing at negative 16? Or couldn't you be standing at positive 16 to be 16 units from 0? So negative 16 and positive 16 are the answers. Now let's look at 4 and 5. Okay, so on problem number 4, again, step 1 is to isolate the absolute value. Notice that you have operations being done outside the absolute value. So we have to undo the adding 4 and we have to undo the multiplying by 3. So remember, we undo adding and subtracting first. So we're going to subtract 4 from both sides first. So that's your algebra skills. That leaves me 3 times the absolute value of m. Right? Then we can undo the multiplying by 3 by dividing by 3. And that leaves me the absolute value of m equals 5. And then we check to make sure it's not a negative distance, so it's not a no solution. So we looked for a negative distance, and it's not a negative distance, so we're good. And we have to be 5 units from 0. So if you're 5 units from 0, couldn't you be standing on negative 5? And couldn't you be standing on positive 5? Right? Aren't both of those numbers 5 units from 0? And then we could write our answer in set notation. Problem number 5. Some people would go, shouldn't you divide by 2? No, because that's inside the absolute value. Isolate the absolute value means to undo anything that's outside the absolute value. And 2a is inside the absolute value. So it is not okay to divide yet, because that is not inside the absolute value or outside the absolute value. So step 1 is already done. There is nothing, it's already isolated. The absolute value is already all alone on the left-hand side. Then we check to make sure that it's not a negative distance, so we're good with that. And now we have to write our 2 equations. So our 2 equations are going to be equation 1 and equation 2. Remember, we are looking for numbers that are 14 units from 0. So we want things that are 14 units from 0. So we have to say what's inside the absolute value. So we're going to say 2a could either be standing at negative 14 or 2a could be standing at positive 14. Because remember, we have to be at 14 units from 0, and there's two different ways you could be 14 units from 0. You could be standing at negative 14, or you can be standing at positive 14. So notice I put what was inside, so 2a could equal negative 14, or 2a could equal positive 14. So that's step 3, write the correct number of equations. Step 4 is then to solve those two equations. So we can undo multiplication by dividing. We can undo multiplication by dividing. So our two answers are negative 7 and positive 7, and that's the work that we expect to see. So we expect to see the two equations written down, and right, one of them had to be negative 14, and the other one had to be positive 14. So now let's look at number 6. Again, step 1, isolate the absolute value. So right now, don't we have an add 6 outside the absolute value? So don't we have to undo adding 6 by subtracting 6? And that leaves us the absolute value of n minus 4 equals 2. Then step 2 is to check to make sure it's not a negative distance. So it is not a negative distance, so we're good to move on to step 3. Step 3 is to write the correct number of equations. Remember, we need to be 2 units from 0, right? So we need to be 2 units from 0. So can't we be at negative 2, and can't we be at positive 2? So that's where the two equations come from, right? The two equations come from the fact that we need to be 2 units from 0. So equation 1 says what's inside the absolute value could be standing at negative 2, or equation 2 is what's inside the absolute value could be standing at positive 2. So are you making that connection that there's two equations because we could be standing at negative 2, or we could be standing at positive 2. And then we can solve those two equations. So step 3 is to actually write the correct number of equations. Step 4 is to solve each of those equations, which we should be really good at by now. Watch your integer skills, right? So make sure that you're not going so fast that you're not adding and subtracting your integers right. So positive 2 and positive 6 are my solutions. So if I plug those back in, it would make those sentences work. Let's look at number 7. So number 7, kids want to subtract 3 from both sides, but that is not correct. You cannot do that. You can't undo stuff that is inside the absolute value. So you cannot undo stuff that's inside the absolute value. That is not acceptable. So notice step 1 is already done. There is nothing on the outside, right? So step 1 is to isolate. There's no operation on the outside of the absolute value. So that it's already isolated. So you need to be able to recognize when a sentence is already isolated. So step 1 is already done. So now we can move on to checking to make sure we don't have a negative distance. Right? So we don't have a negative distance, and then step 3 is to write the correct number of equations. Right? So aren't we trying to be 8 units from 0? So couldn't x plus 3, notice I'm not writing the absolute value, I'm saying what's inside. Notice I did not put an absolute value bar. So make sure you're looking at your work and my work and seeing does the notation match. So we're saying what's inside, x plus 3 could be standing at negative 8, because that would be 8 units from 0, or x plus 3 could be at positive 8, because remember, we're looking from distance from 0. So there are two numbers that are 8 units from 0. Negative 8 and positive 8 are 8 units from 0, right? That's why there's two equations. So we're going to write equation 1 and equation 2 to emphasize that. That's what step 3 is, to write the correct number of equations. Then step 4 is to solve each of those equations. So I'm going to undo addition by subtracting. Watch those integer skills. And then I'm undo adding 3 by subtracting 3. Notice when I rewrote this, this is an error that kids do. Notice this is plus 3. Notice I wrote exactly the same thing that was inside, right? Exactly the same thing that was inside. And then this gives me x equals 5. So my two numbers are negative 11 and positive 5. And that's called set notation. Okay, let's look at a couple more problems. Okay, in this problem, step 1, isolate the absolute value. Do you recognize that the absolute value is already isolated? So once again, you cannot add 8 to both sides because this is inside the absolute value. So that is wrong to do that. It is already isolated. There is nothing, it's right, there's nothing outside the absolute value. So step 1 is already done. Step 2, we're looking at the distance. So step 2, we don't have a negative distance. In step 2, we have no negative distance, so it's not a no solution. Step 3 is to write the correct number of equations. So we need to be 0 units. Distance from 0. We need to be 0 units from 0. So if I say you better be 0 units from 0, doesn't that mean you have to be standing on 0? Right? Wouldn't that mean you actually have to be standing on 0 to be 0 units from 0? So for this one, we don't have two equations because, so k minus 8, so what's inside, if you have to be 0 units from 0, you have to actually be standing on 0. So this one's kind of a special case because there's only going to be one equation because only 0 is going to make that true. And then we can add 8 to both sides, and that gives you k equals 8. See, watch, I'll show you. Here's the original problem. Let's go back and replace k with 8. So if I put an 8 where k used to be and do order of operations, so is that going to give me the correct answer? Isn't 8 minus 8 0, and isn't 0 0 units from 0? So see, that really did work. So there's only one equation for that one. Okay, so number 9, step 1. Do you remember what step 1 is? Isolate the absolute value. So that means any operations that are done on the outside of the absolute value, we have to undo first. So we have to undo adding 4 first by subtracting 4. And that leaves you the absolute value of 6m equals 12. You might want to make those absolute value bars big. Make sure you make them straight so they don't look like a parentheses. Now, some kids might want to divide by 6. You cannot do that. Nope, nope, nope. You cannot. We are now officially done with isolating the absolute value, right? So we've isolated the absolute value, so we're done with that. Step 2 is to check and look to see, do we have a negative distance? Nope, so it's not a no solution. And then we can write our equations. So here we're talking about that the distance has to be 12 units from 0. So aren't there two possibilities? You could be what's inside, right? What's inside could be, so 6m could be standing at negative 12, or 6m could be standing at positive 12. So remember, we have to be 12 units from 0. So you could be at negative 12, or you could be at positive 12 because the distance is 12 units. So those are the two equations that you have to write. So we're going to call this equation 1, and we're going to call this equation 2. And then we're going to solve those two equations. So we're going to undo multiplication by division. We're going to undo multiplication by division. So negative 2 and positive 2 are my solutions, right? So step 1, isolate. Step 2, make sure you don't have a negative distance. Step 3, write the correct number of equations. And so we had 2 because you could be standing at negative 12 or positive 12 to be 12 units from 0. And then step 4, solve those equations. Let's look at number 10. Okay, step 1. Do you remember what step 1 is? Make sure you're looking at your notes. So don't we have to undo subtracting? And don't we have to undo multiplication because aren't those outside the absolute value? So remember, step 1 is to isolate the absolute value. So we want to get the absolute value to be by itself. So we have to undo anything that's outside of the absolute value, right? So that would be the -1 and the times 3. So we're going to undo the adding and subtracting first. So we're going to have to add to undo the subtraction. And that gives us 3 times the absolute value x plus 6 equals 24. Then we can undo the multiplying by 3 by dividing by 3. Don't forget your absolute value bars right here. So let's point to this and let's emphasize that step 1 is now done. Didn't we isolate the absolute value? Didn't we get anything outside the absolute value? And didn't we undo everything that was outside the absolute value by using algebra? Now we're going to check to see, make sure the distance isn't a negative distance. So it's not a negative distance. So we can then write our 2 equations. And do you remember what we're going to write 2 equations? Because when we're saying that you're 8 units from 0, you could be standing at -8 or you could be standing at +8. And then we have to say what's inside. X plus 6 could be at -8 or x plus 6 could be at +8. So do you see where the 2 equations are coming from? Equation 1 and equation 2. And then step 4 is to solve the 2 equations. So we can subtract 6 from both sides. So make sure you're looking at my notation and your notation, right? And then subtract 6 from both sides. So look at the notes that are provided for you. And the 2 answers are -14 and +2. So some students will have, in this step, they'll have the absolute values here, and that's wrong. Notice I didn't put the absolute values there because we're not talking about the absolute value because the absolute value cannot be negative. We're specifically saying what's inside. What's inside the absolute values could be -8 or +8. So it's absolutely wrong to put absolute values when you're writing your equations. So notice that I did not put them there because you can't put them there. It's incorrect to put them there. So make sure you're looking at your work and paying attention to the notes and noticing that we did not have the absolute values there in our notes and when we did the problems because we're talking about what's inside. Okay, let's look at number 11. Okay, in problem number 11, it's asking you to check all equations that would be no solution. So looking at the first equation, would this be a no solution? So the first thing we want to do is step 1 done? Is the absolute value already isolated? Yes. Is this a negative distance? No. So this one's okay. It's not a no solution. Equation number 2. The first thing we have to do is isolate the absolute value, and it's not isolated. So we have to undo. So some people say, oh, it's got a negative distance. It's a no solution. But remember, you have to do step 1 first. So yes, this does have a negative distance, but it's not isolated. You have to isolate first. So let's do the steps and make sure we isolate first, and then we'll check for a no solution situation. Right? So we want to check for a no solution by isolating first. So we have to add 10 first, and that gives us the absolute value of x equals a +7. So it's not a negative distance. So we're okay. So we're looking for things that give us a negative distance to be no solution. Here the distance is 0, and that's okay. So that's not a problem. Here we've got the absolute value is isolated, and we have a -9. So this is a no solution problem. This one we would have to divide both sides by 2 first. And that equals a +6. That's not negative. So we don't have a negative distance. So this is the only one in all of these problems that are going to give us a no solution scenario. Okay, so today we're solving absolute value equations. So remember the steps. Make sure you follow them in order. You isolate the absolute value, which means you have to undo anything outside the absolute value. Then you check to make sure you don't have a no solution situation because you can't have a negative distance. Then you write the correct number of equations. Did you notice In problem number 8, that's the only one that gave us one equation, because when you're 0 units from 0, there's only one option that could be. Notice how these other problems, they had two equations because you could be -2 or +2 units from 0, right? And then you have to solve each of those equations. Okay, we'll see you tomorrow.